All right, thanks for coming. Really a pleasure to be here. See some familiar faces, some I haven't seen for a while, so that's a treat. So I'll tell you a little bit about me, and I have an outline here, so I'll go over that. I worked at the Pacific Northwest National Lab for 28 years and had a good career, satisfying career. But there's more to life than work. And so about 10 years ago, I noticed that the public was getting confused about the conclusions of the scientific community regarding the human role in climate change. And so I started giving presentations to the public about the science of climate change. And along the way, I found that the people were more receptive to the science if they were also presented solutions. And so I started looking out for solutions, and I came across one that made a lot of sense to me. And I've been advocating that ever since, and you'll hear about that. But I want to show some science too tonight, because I know you want to hear some science. So I usually don't show much science, but it's good. Sometimes people need to hear science, so I'll talk about science. So yeah, the key points then are that, the climate is changing, and although it has changed in the past through natural causes, the human influence is really dominating now, and it's causing serious problems that will get worse if we continue down the path we're on. Fortunately, we have the technology available to make changes, and we have policy available to accelerate that technology. So I'll talk about that, and then the role that relationships can play in advocating for that policy. So here's some science. This is a record of a global mean surface temperature since 1880, and you see a general upward trend, but there's lots of wiggles. The annual averages bounce up and down quite a lot, and that's just because the climate system is rather chaotic, because weather is chaotic. There's a 5-year running mean that shows the trends more clearly. Clearly it's going up, but there are some variations that are not really signatures of climate change as well. Now, the climate change is really driven by an imbalance in the Earth's energy system, driven by carbon dioxide mostly, and that imbalance. It happens. It's continual, and so if you look at the energy content of the climate system, you see changes in that reflect that energy imbalance at the top of the atmosphere. It shows that more clearly than surface temperature. Surface temperature is just some measure that is important to us, but it doesn't necessarily reflect the energy balance, energy content of the climate system. And so it's helpful to look at the ocean heat content, because that's where most of the energy content in the climate system is. And what you see is the upper 700 meters. There are still some wiggles, but it's been going up. And if you look deeper into the ocean, there's fewer wiggles. So there's a very clear trend here in the ocean heat content, which reflects this imbalance at the top of the atmosphere driven by the greenhouse gases. And here are the direct measurements of greenhouse gas concentrations for the last 2,000 years. These come from bubbles in ice cores, for the most part. And so from those bubbles, we can measure the concentrations of CO2, methane, and nitrous oxide. And you see they didn't change much until the last 150 years or so. They've really shot up. CO2 has increased by 40% since 1850, and methane concentration has just about tripled. So huge increases in these important greenhouse gases. And so there we are now. What's an update? We're up to 410 now for CO2. So the increase in greenhouse gas concentration is trapping heat. The energy from the sun is mostly absorbed at the surface of the Earth, and then it's radiated outward from the surface in the infrared, and then the greenhouse gases, including water vapor, absorb that radiant energy and emit it back to the surface, which warms the surface, and then also irradiate it back to space, but because the atmosphere is cooler than the surface, there's less energy radiated to space because of those greenhouse gases. And that's the basic greenhouse effect. We're just augmenting that by adding more CO2 and methane. And then the water vapor amplifies it because water vapor content increases with temperature. So there it is. You see a thicker blanket. So I really love to show the data from the ice core records. This is from Antarctica going back 400,000 years. And from the isotopes of water in the ice, we can infer the temperature when the water condensed, and from the bubbles in the ice, and we can also get the concentrations of carbon dioxide and methane. And what you see is wide variations in all three of these. Temperature goes up and down by about 5 degrees C, and this is really the ice age cycles. 10,000 or 20,000 years ago, it was 5 degrees C colder, and now we're enjoying the present interglacial here period. But every 100,000 years, there's an interglacial and then a deep ice age. And in strong correlation with the temperature variations are changes in carbon dioxide and methane. And there, people argue about which is causing which, and really the answer is they're both affecting each other. Now I'm going to use this data to learn something about the climate system, how sensitive the climate is to the variations in the greenhouse gases and other things that affect the climate system. And so we can estimate the temperature change due to a climate forcing if we know a quantity we call a climate sensitivity, which is defined simply as the temperature change over the climate forcing. And I'm going to show evidence that this climate sensitivity is fairly invariant. I'm going to estimate it from one set of data, and I'll apply it to a long data set. And you'll see how well this single value of the climate sensitivity explains past variations in temperature, given estimates of past variations in climate forcing. All right, so from the ice core record, we saw that there are variations in temperature of about 5 degrees, and associated with that are variations in the ice sheets and vegetation that affect the albedo of the Earth, how much sunlight is reflected to space. And we can estimate how much that is, and it's about 5, what we call watts per square meter. And then the variations in the greenhouse gases also affect the energy balance of the Earth, and we can quantify that from our understanding of radiative transfer in the atmosphere. And so we can estimate that forcing, the difference between the energy balance for the glacial period and the interglacial period, that's about 6.5 watts per square meter. And then the ratio of the temperature change to the forcing comes out to about 3/4 of a degree per watts per square meter. So that's one estimate, and we're going to apply this single estimate of the climate sensitivity to the full record of the ice core going back 800,000 years. So the upper panel here shows variations in carbon dioxide and methane and sea level for the last 800,000 years. And from that and variations in the ice cover, we'll estimate the climate forcing from the greenhouse gases and from the changes in the surface albedo. And then we're going to add those together to get the total forcing and multiply that by the climate sensitivity, a single value of the climate sensitivity, to estimate the climate, how the temperature is going to vary. And then we also have the observations from the ice cores. And you see that this simple model of a constant climate sensitivity can explain a large fraction of the past variations in temperature. So that gives us confidence that this single value of the climate sensitivity can be applied to the future as well. Okay, so we have the current concentrations of carbon dioxide and methane, and we can calculate the radiative forcing from those and apply the climate sensitivity to estimate what the temperature change should be for the current values of the greenhouse gases. And it's an increase of about 3 degrees, which is about 3 times as large as the climate has warmed in the last 150 years. And that's simply because it just takes time for the ocean to warm. It's very high heat capacity. So that's really sort of the warming that we're already committed to. Okay, so that's data with this very simple model. Now I'm going to use data to test the full embodiment of our understanding of how the climate system works in a big computer model of the climate system. And this climate model is driven by measured concentrations of CO2 and methane, driven by measurements of changes in ice cover and snow cover, and also changes in the Earth's orbit. Because I neglected to mention that this periodicity here, this 100,000-year variability, that is driven by periodic changes in the Earth's orbit, which affects how much sunlight shines on the northern hemisphere during the summer, and that affects snowmelt. And then that's a very small perturbation, but it's amplified by this albedo feedback. If it's warmer, then there's less snow and less ice, and the following year there's more sunlight absorbed, and it amplifies it, and then the greenhouse gases amplify it. So, so we've driven this climate model with the observed variations in the ice cover, and we've let it simulate the temperature response and also the melting of the ice cap. We're initializing this at 21,000 years ago, which was the depth of the last ice age. All of Canada was covered with ice. And then we run it for 6,000 years, 7,000 years here, and look at how well simulation agrees with the data. And we do it in two configurations. One where we use constant greenhouse gases and just let the orbital parameters change. And then the other is where we vary the greenhouse gases and the ice cover. And what we see is that if we run it with just the orbital forcing only, we don't get any kind of a response at all in the temperature in these different ocean basins and in sea level. Only when we add in the forcing from the ice cover and from the greenhouse gases do we get a response, and it actually agrees very well with the data. The black curves are the data, and there's some data there. So it's simulating a 120-foot sea level rise and warming of 5 degrees in the ocean. So this gives us confidence that the model has the right physics. Further confidence comes from looking at recent changes in the temperature of the atmosphere. The upper figure shows simulations from a climate model for the last 50 years or so, and it shows a warming in the lower atmosphere and a cooling in the upper atmosphere. And then the lower figure shows the observed trends in temperature in the atmosphere. And you see, again, the warming in the lower atmosphere and cooling in the upper atmosphere. And we call that a fingerprint. And so that's running the model with all of the things that we think affect climate. And then to identify which are most important, we run it with only selected contributors to climate change. And so the upper left there is with variations in the greenhouse gases, and there is a warming in the lower atmosphere and a cooling in the upper atmosphere. We run it with changes in the solar flux. We just get a small warming throughout. If we run it with changes in ozone, we get a warming in the lower atmosphere and cooling in the upper atmosphere, and that's partly from the greenhouse effect of the ozone. The aerosols give the wrong signature. Really the whole signature is dominated by the greenhouse gases. So this is the fingerprint of greenhouse gases on temperature. Okay, so then these variations in the greenhouse gases are caused by emissions. And I'm going to focus on carbon dioxide. Methane we don't have such good data on, but we know very well how much fossil fuel we're using and how much forests are being burned. And you see that our emissions have increased a lot in the last 60 years. A lot of coal, starting in Europe and the US, but now expanding to China and India. But also a lot of oil and gas driving up our emissions of CO2. And the forest burning has declined recently. And various activities are contributing to those emissions. There's our electricity and heat production is about a quarter of it, and transportation is 14%, industry 21%, building 6%, and agriculture, which includes methane and burning of forests, is a big source as well. So there's no one single source of the emissions. And so we have to, if we're going to prevent the warming that's happening, we have to address all of these sources. So we really do have a consensus now in the climate science community. 97% of climate scientists agree with the conclusion that humans' activities are really driving the recent warming. Just a few outliers left now. If you weren't feeling well and you went to a physician and the physician said, oh, you know, done some tests, and, you know, you've got cancer, you need to have surgery and change your lifestyle. Well, you may not like that, and you may go for a second opinion. But if you go for like 30 opinions, and only one of them says, you're fine, don't worry about it, are you going to listen to that person? Okay, so it's serious. We're really just seeing the effects. We're just getting started. We have enough fossil fuel to have triple the emissions by the end of the century, and we can burn for hundreds of years. We can warm the earth a lot. And so we're seeing now extreme heat. Twice as many heat records are set as cold records now. We're lost 25% of the mountain snowpack in the Cascades. And our runoff in the summertime is diminished. And then we've had the huge wildfires all over the western US, partly because of forest management, but also because of the warming, the loss of snowpack, the soil dries, the vegetation dries. Greenland is melting. We have satellites that measure the surface of the Greenland, and so we have good data telling us that Greenland melting is accelerating. Sea level's rising. Now Miami's getting flooding at high tide every day, and coastal flooding, huge coastal flooding when tropical storms come through. In the Midwest, precipitation now is more intense. Good data supporting that, and our hurricanes are getting stronger and wetter. Houston has had three 500-year floods in 10 years. And then the CO2 is dissolving in the ocean, and that's hard on the shellfish and the corals. And then our tropical diseases are expanding to mid-latitudes. So lots of serious stuff here. So what does that mean for here, bringing it home? Just think, who was around in 2015? Remember the year 2015? It was an abnormally warm year. There was a blob of warm water off the Pacific coast. And although we had normal precipitation, the mountain snowpack was about 30% of normal. And it was very hot that summer. That snow melted off really fast, and the soils dried, and the the streams dried up. They had to shut down the Rosa Canal on the Yakima River in May to save water for summer irrigation. And orchards were lost. And then we had record wildfires in Washington State and smoke, of course, and our farmers lost $1 billion. So that it really gives us a window into the future. Years like that will be normal by the end of the century without action on climate change. And so this causes economic damage, and economists have looked at how much damage is caused by a warming Earth. The figure on the right shows estimates of the damage to the US GDP for various warming amounts. And obviously, the warmer it gets, the more damage there is. Sea level rise and storms and snowpack and all sorts of effects. And they're pretty serious. Just by point of reference, during the depth of the Great Recession, the worst 18 months, the GDP declined by 4.2%. That's comparable to the economic damage for a warming of about 8 degrees Fahrenheit. Now, that much warming is likely to happen if we don't do anything to reduce our emissions. On the left side shows different emission scenarios. It's the accumulated emissions that matter because CO2 stays in the atmosphere for a long time. And so without any emissions controls, then emissions triple and accumulated emissions are huge. And driving all sorts of warming. Now these different dots here, the red dots are for this scenario. They're different amounts of warming because we're not certain exactly how much the Earth is going to warm. The climate models, they don't use that ice core data. They don't specify the climate sensitivity. They simulate the climate sensitivity as part of their physics. And so there's different estimates of the climate sensitivity from the models. And so they get a range of responses to that emission scenario. And you see, in some cases, as much as 15 degrees of warming or as little as 5 degrees for that scenario. But a very likely estimate is about 8 degrees of warming, producing economic damage comparable to the Great Recession. Now, the difference between the Great Recession and the warming at the end of the century is the Great Recession, we were able to borrow our way out of it. We pumped in trillions of dollars into the economy and borrowed our way out of it, and now we're recovering. For the climate change, this is a sustained damage. It's not something we can borrow our way out of. We're stuck with it. And so a 4% hit on GDP would really be harmful. So we had choices on emissions. The blue curve there is it's similar to the emissions that the world pledged in Paris in 2015. There was a climate agreement, and all the nations of the world pledged to reduce their emissions by 2040, bring it down. So it's quite a lot less than the no policy emissions, which is good. And so that corresponds to the blue points over here. And so the damage is reduced to maybe 2% in GDP, which is better. We'd like to get to the green curve, and policies that I'm going to describe today will show you how we can get to the green curve and really limit the warming and limit the damage. Okay, so because of all these impacts and things that are happening to people, where they live, the flooding and the fires and wind damage and so on, people want solutions. They want Congress to act. 62% of the American people want Congress to do something about climate change. It doesn't sound like a strong majority, but compare that with only 16% don't want Congress to act. So it's about a 4-to-1 ratio. People want Congress to act. If you look at it on a county-by-county basis, in very few counties do less than 50% of the people want Congress to act on climate change. So, fortunately, we have technology has come a long way, giving us options for replacing the greenhouse gas, the fossil fuel that is driving our emissions. Now we have solar and wind that are cheaper than coal and competitive with gas, and there are many options on storing energy to deal with the variations in energy production by solar and wind. If you combine those with hydroelectric and nuclear, it's clear that we can meet our energy needs in the future at lower cost. So that's good. Transportation is one big emission source besides electricity. So we were getting a lot of progress on electrification of vehicles, electric cars, and now there are electric buses in a lot of cities. We could have electric trains if we chose. Tesla's developing an electric long-haul truck. There are electric ferries in Norway, and they're coming to Puget Sound. And there's even an electric airplane. There's an airline based out of Vancouver that is going to be all electric real soon. There's also hydrogen fuel cell vehicles. Toyota makes a car. They are making a hydrogen fuel cell long-haul truck, which is really good because that can refuel really quickly. New Holland has produced an ammonia fuel cell tractor that farmers could use. And we suspect that there will be hydrogen fuel cell airplanes at some point too. And they are mostly available, increasingly affordable. The electric vehicles are already cheaper to operate than internal combustion vehicles, and it won't be long before they'll be cheaper to buy too, because they're just inherently simpler than internal combustion vehicles. Battery costs have come down by 35% in just the last year. Yes.
Yes, question. Do you still get a gain from electric transportation if your electricity source is from coal?
Right, so yes, the transportation, electric vehicles only, well, they do save some, but they save a lot more if your electricity is produced without fossil fuel. And so we're seeing a lot of progress in the decarbonization of our electricity, and that's what needs to happen. Okay, those are only two of the sectors that I showed there for emissions. There are others, other ways we can reduce emissions. There's a book called Drawdown, edited by Paul Hawkins, that describes 100 different substantial ways we can reduce emissions and even pull carbon out of the atmosphere. Food is a big source of emissions, methane and carbon dioxide. And there are lots of things we can do on food. Educating women actually would make a difference, because if you educate women, they tend to have fewer children, and population is a big driver for emissions. Building energy efficiency, there's opportunities there. Land use, preventing the burning of the forests is really important. And progress on materials, for example, refrigerants is a big opportunity there. Okay, so those are available, but they're not coming along fast enough to prevent a lot of accumulation of carbon dioxide in the atmosphere. We can save a lot of economic pain if we accelerate the process of technology, both through investment in our federal investment in private R&D, but also through incentivizing the use of those technologies to prevent mass dislocation of human populations and economic damage and environmental damage as well. So we need incentives. So let's talk about what a good policy would be. Obviously it needs to reduce emissions quickly, but not too quickly. We don't want a crash course, zero emissions by 2030. That would be very difficult to do and very expensive and damaging to the economy. So we want it to happen fast, but not too fast. We also want to use incentives that drives choice rather than heavy-handed mandates. And this policy needs to be fair. It needs to drive down emissions by the people that are doing the emitting, and not hurt the poor, who tend to emit much less than the wealthy. It also needs to be durable. It needs to not depend upon which party controls Congress or the presidency. It needs to get passed by Congress with bipartisan support, and I'll talk about that. And of course, it needs to be healthy for the planet and for the economy. So there's a policy that Citizens Climate Lobby has been advocating for 8 years now. It's called a carbon fee and dividend because it simply puts a price on fossil carbon at as closest to the source as possible at the mine or the well or imports from other countries. And it's a steadily increasing price that is charged to the fossil fuel extractors, and then they'll pass those costs on down through the stream, and it pervades the whole economy. And the revenue from that is collected by Treasury and then immediately returned back to the economy as an equal dividend to every resident. No matter how much carbon they use, everyone gets the same amount. Basically divide by the revenue by the number of people, that's how much they get. People can do whatever they want. They have the total freedom to do what they want with it. So that's the basic thing we've been advocating. I'm happy to say that we have now legislation introduced in Congress with, which basically is the embodiment of this policy with bipartisan support, bipartisan sponsorship. It has 32 representatives in Congress supporting this, the Energy Innovation and Carbon Dividend Act. And so it's going to be scored by the Congressional Budget Office, and our job now is to build the political will for this legislation. How it works then, in addition to the carbon fee and dividend, there's also a border adjustment and some limitations on a regulatory adjustment. So I'll talk about each of those. So the fee then starts at $15 a ton of CO2 emitted from coal, oil, or gas as far upstream as possible. And then it increases by $10 a ton a year. And that $10 a ton is equivalent to, in terms of gasoline, 10 cents a gallon. So the price of gas goes up by 10 cents a gallon a year. And it increases until CO2 emissions from the US decline by 90%. It's a big reduction, but that's the goal. So that's basically a carbon tax, and there are two knocks on the carbon tax. One is that it's pulling money out of the economy, giving it to the government, and that's a drain on the economy. The other knock is that it's regressive. It's hardest on the poor because they spend a larger proportion of their income on energy. So I'm going to deal with those in a little bit, but first I just want to talk about the positive aspects of this carbon fee. It's very simple to implement. There's just a handful of companies that extract fossil fuel or import it, and so you keep track of how much business they do, and so it's very easy to collect the revenue from the fossil fuel companies. It's very transparent. Everyone knows this, and predictable. Everyone knows the price is going up by $10 a ton per year, and so individuals and businesses can make decisions based upon this predictability. So big decisions really need that. And it's also, it's hard to gain, unlike other policies. So business can make rational decisions about moving away from carbon-intensive products. And people can too. Oh yes, and what's really important for getting it passed is that the fee on agriculture is rebated to farmers because farmers are an important voting bloc. We need their support, and frankly, they will not support this because they use a lot of fossil fuel in their operations. They're not going to support a climate policy that does apply this fee to their fuel. Very practical exemption. Military fuel is also exempt, and I'm not sure why, but that's the way it is. So the farmers are getting the benefit of the carbon reductions, and I'll talk more about that. So then the second part then is the dividend. So this comes in equal shares every month to everyone. Adults get a full share, kids get a half share, and people can do whatever they want with it. They can pay more for fossil fuel if they want, or they can use it to buy an electric car, or go out to eat, or get a bit better medical care, whatever they want to do. And there's been studies of how this affects the family pocketbook. And this dividend means more to poor people than to rich people. And so generally, the poor do better than the wealthy on this. Overall, 70% of families come out ahead with this policy. For the lowest quintile of family income, 93% come out ahead. So they're pretty well protected. There are exceptions, of course. So then there's a border adjustment to protect our international trade, because this is a price signal in the American economy. It makes American products more expensive. The American people can pay more for those products because they have this dividend, but how does the US compete in the international realm? We deal with that by applying basically a tariff on goods imported from countries that do not have an equivalent price on carbon. So the country wants to import or export to us. We're the world's biggest consumer nation. They've got to have an equivalent price on carbon. Otherwise, there'll be a tariff that balances the playing field. This also incentivizes our manufacturing companies to stay in the country rather than moving to a place without a price on carbon. The revenue from these tariffs then is given to our exporters to help them stay competitive. So this will induce, China and India to have an equivalent policy. Then the fourth element, it prohibits the EPA from regulating carbon dioxide as a pollutant. In 2007, the Supreme Court ruled that CO2 was considered a health risk and therefore covered under the Clean Air Act, and the Obama administration therefore implemented the Clean Power Plan, which was subsequently challenged in court. But there's still the potential for EPA regulating CO2, and so this says, nope, EPA has no jurisdiction over CO2 emissions as far as climate is concerned. They can still regulate other pollutants. The CAFE standards on fuel economy of vehicles holds, water quality rules hold, and so on. But if certain targets are not met, then EPA can regulate, and if those targets are not met, then the rate at which the fee increases over time will increase. So instead of increasing by $10 a ton per year, it will increase by $15 a ton per year. But we're not exactly sure how quickly emissions will decline. The targets are 40% reduction by 2030. That's pretty ambitious, but that's really what's needed to limit warming to 2 degrees, and a 90% reduction by 2050. Okay, so how well will this work? I'll argue that it's effective and it's good for people and creates jobs. So, as I said, these targets are 40% reduction by 2030, 50% reduction by 2090. That would be very effective if we could get that, and therefore it has widespread support by economists. There is a statement in the Wall Street Journal published in January, signed by 3,500 economists, about 20 or 30 of them Nobel laureates in economics, chairs of the Federal Reserve, and so on, all supporting the carbon fee and dividend concept. Because it's simple, comprehensive, and effective. It's also good for people. About 100,000 people in the US die early deaths because of air pollution from particulates, soot, and the ozone produced from NOx emissions. And if you're reducing emissions by 90%, it's going to save a lot of lives. And it's good for people's pocketbooks. Most people come out ahead, and it helps out particularly the low and middle income people. The wealthy people don't tend to come out ahead, but they have the resources to reduce their emissions. They can go out and buy an electric car. They can make their house zero energy. It also creates jobs because people go out and spend their dividend on whatever, and the analysis indicates an increase in jobs of tens of, or hundreds of thousands, maybe millions of jobs over the next 10 years in all sorts of sectors of the economy, except, of course, fossil fuels. Those jobs go away, but there are all sorts of new opportunities in health, in retail, and information technology, education, lots of areas. Okay, but there are some obstacles. And you can guess that there's going to be objection from the fossil fuel industry. Their net worth is tied up in the assets that are in the ground. And if we're going to stop climate change, those assets, the large majority of them need to stay in the ground. And so you can expect them to fight it. The coal industry in particular is very threatened by this, and they have fought it for decades, and they will continue to fight it. There's also challenges with the human psychology, and I'm going to talk about that, and there's also problems with tribalism. So we've actually seen some surprising support from the petroleum industry for a more modest price on carbon. What we're advocating is a price that goes up to $200 a ton after 20 years. There's another policy, similar carbon dividend plan, that starts at $40 a ton, but it only increases by 4% per year. That's a more modest price. It has support from 4 oil companies. And I believe the reason they support it is that lets them compete better with coal, because they have a lot of natural gas they're getting from fracking, and that has a lower carbon intensity for the same amount of energy produced. So they can put coal out of business and get more electricity produced by burning natural gas. And also, though, other reasons they support this is it does provide market certainty, which is really important for any business. And another element in that particular plan is that it protects them from liability for historic emissions. The legislation that we've been advocating does not protect them from liability. Our feeling is let the courts sort that out. We're looking toward the future, not the past. So they have not issued any statements of support for our legislation, and it remains to be seen how much they will oppose it. So we may have some challenges that we'll have to overcome. And the other thing is that we're designed to respond to sudden threats. You know, whoa, what was that? You put a frog in a pot of water and turn the stove on, and they won't jump out. They just get used to it, and used to it until they're cooked. And people don't deal with these slow threats. They don't even perceive them often. And so it's really hard to get people motivated to deal with the threat of climate change. If you look at the list of things that people are most concerned about, at the top is terrorism. You know, the number of people that die from terrorism is really low. But that's at the top of the list because it's a very sudden, scary thing. And then, of course, the economy and jobs. But climate change is way down on the list. Only 3% are really concerned about that. And so that's a challenge. This is a rather old survey. I think that percentage has gone up now because climate change is starting to hit home with the fires and the floods and so on, the smoke. And then tribalism. It used to be there wasn't much difference between Republicans and Democrats on climate change, but now there is, and that's a problem because people start taking entrenched positions and start to use climate change as a wedge issue rather than a bridge. and that's a problem. So how are we going to overcome these obstacles? Citizens Climate Lobby has a strategy that I really think a lot of. We've been growing a lot. Now we're over 100,000 volunteers, and we span the political spectrum. We have conservatives and libertarians and liberals and moderates, and we work together because anyone who cares about climate change is working together for various reasons. And we're organized into all these chapters around the country, so the Tri-Cities chapter is quite active. We have 360 members in the Tri-Cities, but we're all over the state and all over the country and all over the world. And we are learning how to use our personal and political power. And I'll explain what I mean by that. But really it starts with our relationships by treating everyone we meet with respect and appreciation and gratitude. And that goes a long way. And so we also listen and identify common values rather than look for differences, because we need to work together. We need Congress to pass this. We can't do it without Republicans as well as Democrats. In 2008, the Waxman-Markey cap-and-trade legislation passed in the House, but it stalled in the Senate. Even though Democrats held 60 seats, they still couldn't get it passed. They didn't have any Republican support, and even some Democrats opposed it. So we need Republicans involved in this, and we're seeing a lot of progress on that. So our challenge then is to demonstrate the bipartisan political will for this legislation, which would be a durable national solution. So to do that, then our values we're really focused on this particular legislation. There are many other approaches that are not bipartisan, and we don't put time into those. And then relationships are a big part of our approach. Building friendships, finding common ground, and working with whoever cares about climate change, and speaking up, exercising our voice, and engaging people. And we really participate in the political process. We really believe in democracy as citizens, and are very optimistic about that. And we also take data seriously, and we listen to people with different views. So how do we do this? There are various ways to build political will, particularly bipartisan political will, and so we reach out to people, we talk to people, family, friends, neighbors, whoever. We go to public events and table, we show films and give presentations. I give a lot of presentations. I'm giving 6 this month. We also work with the media. We write a lot of letters to the editor. If you subscribe to the Tri-City Herald, you've probably seen some of my letters. We have op-eds also. And we meet with the editorial boards. We got a really strong statement of support of our legislation from the Tri-City Herald editorial board. We also do radio interviews, and we use social media quite a lot, Facebook and Twitter. And we also seek endorsements from business leaders and thought leaders, because politicians pay attention to them. And so we work hard on that. And we lobby directly. We go to Congress and meet with their staff and members of Congress, and we, of course, write letters and send emails and call them up. We get as many people as we can to do that, get their attention. But we don't contribute to political campaigns. We don't campaign for anybody. We just work with whoever's in office, because we need everybody behind this. So we found that relationships can overcome obstacles by building that trust and respect and cooperation that really is essential to overcome obstacles. And we talk a lot about what we're trying to say. We're not really against things, we're not against business corporations. We are trying to say what is dear to us. And that varies from person to person. Some people love fishing, they're trying to save their fish. I love snow, I'm trying to save the snow. And there's lots of things, farms, whatever we're trying to save, animals. And that gets people passionate. And then seek common ground, and sometimes it's surprising. We've got support from not only conservative fishermen, but people who really don't care about the climate, but they really value energy independence or energy security. And so we get support from them for this legislation. Always trying to build consensus for policy. We don't want a partisan solution, we want a consensus. And that's the way Congress generally works. About the only legislation they pass is pretty lopsided. Particularly in the Senate. And we're finding that our solution is consistent with a lot of common values. The liberals tend to value making polluters pay. Conservatives really have the same attitude, just different words. They say it's personal responsibility. Same thing, really. Republicans also value market-based solutions, and this is certainly a market-based solution. And a small government does not grow government because all the revenues return back to the people. With a lot of common ground, because this is a very simple and effective policy, it's very efficient, and good for jobs, health, economy, and fair to the poor. So a lot of common ground for agreement. So I'd love if you would join Citizens Climate Lobby. I have a sign-up sheet out there. Go check it out. There's a lot of good material there. And you can also learn about our legislation at the energyinnovationact.org. And then start sharing, talking to people about climate change. Our group cannot reach everybody, so we need more and more people involved and advocate for this national policy. Tonight, I'd like you to register with CCL, and also I have some comment forms here. Now it's time for questions.
Can we have, I want to research a little more, HR 763, do we have to,
Yeah, I have.
I cannot decide now, okay, this is
Okay.
because I want to,
I have more.
What?
Oh,
I couldn't hear what you were saying.
I'm saying, it doesn't work anyways. Okay. I'm saying that I want to learn more about,
Okay,
HR
here's a summary about the legislation.
before I write anything.
Yeah, you can do
Some
that.
time because I'm like, okay, let's think about it.
And you can
Sounds great, but
find out my address, and you can mail. You can mail your form to me if you want. But you probably have some questions, so this is a good time for questions.
Okay.
Back here.
Yeah, Steve, comparing the various countries of the world, their contribution to the CO2
Yeah.
emission, where is the U.S. at relative to some other countries? Are we the main producer, or are we,
Yeah, good question. So, in terms of accumulated emissions, which are really important, the U.S. is way ahead. But in terms of emissions this year, we're in second place behind China. China passed this up about 6 years ago. So they are the biggest emitter, and their emissions are still growing. And actually the U.S. emissions grew last year, to our disappointment.
did China participate in any of the international
Yeah.
regulation?
Yeah, so the Paris Climate Agreement, the only nations that did not agree to reduce their emissions were Syria and can't remember the other one, but some other dysfunctional country. So every country has pledged to this, and of course the U.S. right now is pulling out, so that's a problem. But we hope Trump will sign this legislation. So we'll see. But yeah, China is the world's biggest investor in solar and wind and hydro and nuclear. But their coal use, I think their coal use is almost flattened out. They are adding coal plants, but they're also retiring inefficient ones. And they're going to be bringing their emissions down because they have an air quality problem, and they want to stop climate change. They have a lot of risk from cyclones and drought and all sorts of impacts. Okay, you have one.
Do you believe that it's fair to the poorer, more energy-starved countries in the world to take away from them the simple, easy energy production we had that made us rich?
Right. Yeah.
And now they've got to work with solar and...
Yeah. Great question. So India, one of the poorest countries in the world, they started adding a lot of coal to get their electricity up. Now they're canceling their coal contracts and they're adding solar. It's cheaper. Yeah. Jim.
My curiosity as far as solar is concerned, why it has not been as effective in this country and all the resistance. It seems to be, I looked at it myself and I felt like I had to stumble over the city of Richland about 4 times before I could get any. It was not cost effective to me because of that.
Yeah, so, I mean, we live in a part of the world where electricity, I don't think there's any place in the world where electricity is as cheap as it is here. However, and that's because of our hydroelectric.
Sure.
However, we've pretty much maxed out on our hydroelectric. And so if we want to electrify our transportation, we're going to need more electricity. And where's that going to come from? So we're going to need wind and solar and nuclear and other stuff. And we also need more storage. These small modular reactors can play a role. They can vary their output, which is really great. So there's lots of opportunities here in the Mid-Columbia because we use relatively less carbon than most areas of the country. So we're really going to come out ahead with this policy. We're going to get all these dividends and we're not paying that much. Our electricity is almost carbon-free. It really is carbon-free. So we're going to be doing better than most parts of the country.
As you look at that, as far as the balance in solar and some of the other things, what about the issues associated with production of equipment for solar, heavy metals, all these other things that you have to deal with as far as manufacturing?
Yeah, so we definitely need all that stuff. And I haven't seen any predictions where we're going to run out of that, but potentially. And there are different ideas about producing solar other than the way we're doing it too, so that could lead to some more opportunities as well. Over here.
Of course, through the last, 40 years or so, there's been a general public opposition, particularly those that are concerned with the environment, opposition to nuclear. Comment on trends and that changing, if it is changing.
Yeah, that's a really good question. So, numerous times when I've spoken to the public about our policy, some anger comes up. They'll say, you're an environmentalist, you have opposed nuclear energy, and I'm angry at you. And I've never opposed nuclear energy. There certainly are a lot of people who care about climate who see an important role for nuclear energy. There are, though, also other people who care about climate change who think we can do it without nuclear energy. And that's a debate. And I say, let the market decide. Put a price on carbon to account for these costs of carbon that consumers are not paying. Consumers aren't paying for the climate impacts of carbon. They're not paying for the health impacts of carbon. They're not paying for the cost of the military, ensuring access to Middle East oil. That's all socialized. Put a price on carbon that accounts for that. Let fossil fuel compete with nuclear and wind and solar. We'll see. Nuclear has its work cut out to get its cost down. It looks does pretty well. Probably better than just about any other plant.
Don't you think it's a pipe dream to expect a government organization to collect billions of dollars a year and move billions of dollars a year back out and not lose anything in the middle? I don't believe that will ever happen.
Good question. So let's talk about Social Security. We pay a lot in Social Security. Who's it? Okay. You're pretty young. Are you paying into Social Security?
Yeah, it comes out of my check.
Yeah. When do you think you're going to get it back?
I've heard that it's not going to be around by the time I'm able to collect. So
But you're still paying into it. Yeah. So the beauty of the carbon fee and dividend is it's every year. You know, there's no wiggle room here. The legislation says there is some administration cost. We acknowledge, but there need to be limits on that because they estimate it's like 8% initially because the revenue is low, but then after it spins up and after, it needs time to spin up, after 5 years it goes down to 2%. I think it should get lower than that, but regardless, the legislation is written to say after those administration costs are paid for, everything goes to the people. British Columbia has a revenue neutral price on carbon. Their finance minister doesn't get paid if he can't demonstrate that it's revenue neutral every year. And we can make it ironclad. No wiggle room. Social Security, there's all sorts of wiggle room. There's no wiggle room. And that's why I'm confident that it's going to work. Yes.
In this legislation, then what agencies manage this process of inflows and outflows? Who's assigned responsibility to
I
make this work?
think Treasury collects it. There's a role for EPA in determining emissions, I think. I'm not real clear on that. One other thing I wanted to say.
There will be a whole enforcement organization build up. There
Yeah,
will be an organization that handles the money build up.
yeah.
And there will be local offices where
So,
they
as I
determine who
said-
gets the checks and
As I
so
said,
forth.
there's a
And it's
small-
gonna, I bet you it goes to 25 to 30%.
As I said, there's just a small number of fossil fuel companies. So it's very simple to collect the revenue.
But the disbursement goes to 300 million.
So we have Social Security that disperses a lot of checks. We have welfare that disperses a lot of checks. We have IRS that people interact with, hundreds of millions. And so we know how to give
And
checks
the
to
government
people.
has, 500,000 people salaries involved in that process. And this is another process on top of it.
Yeah, and so these mechanisms are largely set up, the only thing is really to identify who's a legal resident. And they have to have a social security number. And, it's pretty straightforward to do this.
But it sounds like, if I understood you right, it's the same amount for every person.
Yeah.
So determining the distribution does not have to be calculated,
Yeah.
varied based on people's income.
It's a
They don't
no-brainer.
get checked that way, it's,
Yeah.
is that right?
That's right. It's a no-brainer.
It's sort of like the Alaska.
I don't doubt that they can
payback.
send the checks
Yeah.
out, okay? But there's gonna be
Yeah.
something gone from the collection by the time
Yeah.
you get your
So,
dollars.
and another way to look at this is, can you think of a better way to reduce emissions? Regulations?
I have a question. I don't might be, I saw this movie. It's called, have you seen it? Cowspiracy, one guy-
Cowspiracy, yeah.
So is there any, what is the truth in this? Like he was saying, like the emission from
Okay,
94 million cows.
good
whatever.
question, good question.
Another-
So this is not the only solution to climate change. It deals with carbon dioxide emissions. It also deals with emissions from refrigerants. That's it. It does not do methane, doesn't do emissions from use of agricultural fuel. And it really doesn't deal with agriculture. And I think the next step will be a legislation that will focus on agriculture. It will give farmers credit for sequestering carbon in the soil and incentives to reduce methane emissions and credit for taking care of trees and dealing with the methane emissions and because that's a big deal.
Yeah, but
It
how can
was
the
a
farmers
quarter.
reduce the methane emission
Yeah.
unless they reduce the number of cows?
Yeah,
Is there any other way?
so there could well be a price on emissions from cows, and cows, certainly the emissions from cows vary somewhat, but they could just take a lowball estimate and apply a fee on that. I don't know, no one's talking about doing that, but that is something that could be done after this is in place, because this hits the majority of the emissions from the U.S., but the methane emissions are very important. And eventually, we'll have to deal with it, but that could be 10 or 20 years down the road. Yeah.
I've heard you, and you mentioned that to me, we had lunch the other day, Catherine Cahill.
Oh, yeah.
She's part of the Citizens Climate Lobby.
She's on the board, yeah.
And, heard her describing this CO2 blanket,
Yeah.
use that sort of terminology.
Yeah.
So the things we're talking about here are to try to drive down the CO2 gases that make that blanket thick and holding in the heat, right?
You're right, yeah.
Is there any sort of chemistry or any sort of technology that can actually work on the blanket
Right.
once it's, to break it down in some manner?
Excellent question. So there's one you've probably heard of. It's called photosynthesis. It's fairly slow, but it is pretty cheap. But there are also some artificial mechanisms that people are developing that would be faster. But the challenge is to make them economical. And the measure of how effective they are, or how economical they are, is compare the cost of removing a kilogram of carbon from the atmosphere with the price that people are paying on this policy. If it's $100 a ton of carbon is what our price is at, then they have to be able to do it for less than that. And they're not there yet, but hopefully they will. There is some incentives actually in the legislation for doing that. There's some reward for that, some compensation.
I was thinking, because if maybe there's more investment in those technologies,
Yeah.
there's some incentive
Yeah.
there, maybe they'll, catch up.
Yeah.
And-
So it's just they would get compensated at the current price on carbon at that year. And so it starts out really low, $15 a ton. No one can do it for that. Maybe they have to wait until it reaches $100 a ton before they can make money doing it.
But I mean, maybe if you invest now, take a chunk of money, let's
Yeah.
go whatever, and say, okay,
Yeah.
take the money now, do it fast.
Yeah, and there are, the government is funding people to try to develop it. There's private investment too. So hopefully they can do it. It's hard to say. I think thermodynamically it's challenging because CO2 is a very stable form of carbon. But there are a lot of ideas out there and people are motivated, so hopefully something economical will come out that can scale to the scale of the problems that we have. It has to make a difference.
One more question about this dividend. Okay, so like the tax is paid per like so many tons of, let's say coal, and the emissions. So they pay fixed amount of money, but then they will increase the prices, right?
Yes.
So then, but then the tax is going like, is it like percent? Or is the tax going to increase?
The
Or
price
is it fixed
signal,
price?
the price is on the amount of CO2 emitted by that fuel, and so that price, the cost is passed on down through the economy, ultimately to the consumer. They don't know how much carbon went into that product, they just know that the product is more expensive. And they have their dividend and they'll see that, oh, this carbon-free product is cheaper than this carbon-intensive product, and they can make the decision.
Okay, because I was thinking, if they, but this is good, because if they like, they pay the tax, increase the price, then they get the dividend, but the dividend won't be enough to cover the new price.
Right.
Like,
Yeah. So once that
decision.
price gets to be really high, there's going to be big differences between carbon-intensive products and carbon-free products, and so it'll be obvious which consumers will choose, and utilities too that are producing electricity. And people can see, oh, it's going to be in 10 years, gas is going to be $1 more a gallon. The next car I buy is going to be an electric.
One of the arguments that I've heard, or I've been maybe even countered, I guess, by people on, presenting skepticism, I guess, to a plan like this, is the economic impact on our nation of producing plastics and steel, even,
Yeah.
and because of the carbon emissions that are involved
Yeah.
in that. And the fact that there's so many things made out of petroleum products,
Right.
and what that's going to do to our
Yeah, I
economy.
think there's a bit in the bill where they, I think they're not doing it at the mine or the well. I think they're doing it closer to the refinery, and there's a point where they can determine whether it's going to be used for fuel or for plastic, and so they can waive the fee on plastic.
Oh.
So I think that, yeah, I think.
I'm not sure they should waive the fee on plastic.
Well, yeah, right. There are other reasons to
Yeah.
reduce plastic, but I mean, I think, yeah, well, anyway. But for steel, we need a process that can make steel that doesn't use a lot of carbon, and there will be incentives to do that. The whole world needs to come to terms with that process. And
How much steel do we make in this country anyway?
not so much anymore, yeah.
Most of it's overseas.
Right.
But you still need it as far as the world economy is concerned.
Sure, yeah.
We need to look at it from that point of
That's
view.
right.
As far as the world economy is
Yeah,
concerned.
yeah.
I realize that we're all tribal in some respects. I think that's a good point to make.
Yeah,
How we
yeah.
view things.
Right,
And,
right,
we need to think about our neighbor with respect.
right.
Any other questions from the group? Well, first I'd like to say, Steve, thank you.
For listening.
Well, I appreciate your
Good
time and
questions.
effort, and this will give us a lot to think about as we look at our responsibilities in the world we live in.
Yes, it's our world, isn't it?
Yeah, it is. We greatly appreciate your time.
It's the only one we have.
It is. And we haven't been able to find another one like it either, so.
Working on it too.
So,
We may hear
yeah,
about that in a week or two.
everyone got information on the legislation, if you could write on that form, I'd appreciate it. But if not, then oh yeah, there's more, there's a, so I've got our climate scientists at the lab speaking to the public about climate science, and it's a monthly series we call Climate Science on Tap.
Okay.
And so our next event is on Thursday, May 9th, and it's about soils, and microbes in soils, and there's information about it out there, I believe. And there's also, if you'd like to bicycle, there's a bike ride for climate that I've organized. It's a fundraiser, and that's on May 4th, so there's a flyer on that.
So where do you meet?
The bike ride?
No, the,
What is the meeting?
The talk on climate science on tap is at Venetia Restaurant, which is out on George Washington,
yeah,
north of Richland. Yeah,
Oh,
well,
yeah. There's lots of things we're doing
yeah,
to
yeah.
engage people.
Well, I think most people are confused. It's hard to see the bigger picture, if you will.
Yeah.
I think that's what we need to be able to get our arms with and see the beginning to end picture as far as those kind of things.
Yeah. I hope it was helpful.
Oh, it definitely was.
Good.
We'll probably be arguing about it for another couple of months for sure. We will have a conversation about it. We try to have conversations.
Yes. Respectful.
Yeah, respectful conversations, and we do it because we get to do it, so, thank you. Any other comments or questions for anyone? Thanks again, Steve.
All right.
Very nice.